Before we dip some more into polygon modeling examples, some complex modeling, I want you to see some problems I talked about in earlier lessons, and that is artifacts and problems while we are modeling with subdivisions. Okay. For instance, here we have 4 cubes that look almost identical, but they are not. So let me show you what I mean here. Select this first cube and I will press the S key, so we will have it in our center view. Okay, and now if I deselect the cube, if you can see right here is an artifact. I really hope you can see it, and let me select this cube once more and you can see why. Let me just disable this generator, this hypernerves that adds this detail by pressing Q. Okay, and you will see that I have 2 triangles here, and as I mentioned, it all looks fine, it's perfect, but once you subdivide the mesh, once when you have to with organic or smooth objects with subdivision surfaces, this is what will happen, and you will see a small artifact here. It's a problem, it's a bulge that shouldn't be here. It's really, this is a really most simplest example I could think of. Okay, so let me go to our next candidate here. We can also press, for example, if you want to center all our objects, we will press the H key that will center all objects. Okay, it will frame the whole scene. So now we can press the S key, and basically here we have another type of artifact. It's called an N-gon artifact, and if I disable my hypernerves generator with my Q key, okay, you will see that we have an N-gon here. As I said, N-gon is a polygon which has more than 4 sides, and now if I just deselect this, you will see that we have a inconsistent surface here, sort of a bulge or some sort of something is wrong here. Okay, and many think that adding subdivisions will solve the problem. Okay, well, it won't. It just makes problem to be much worse. You see, now you can actually see a bulge. Okay, let me decrease that subdivisions, something normal. Okay, 2. The next candidate that produces artifacts is this one, so I'll press the S key again to center on that here, and in this current situation we have poles. This is a pole. Pole is basically when there are more than 4 edges connecting into a single point. Okay, so let me disable the generator, and you will see it also looks superbly fine when it's not subdivided, but once when I enable hypernerves, you will see that we have some problems in the surface here and here, and that's why I'm always telling you to use quad polygons. They're predictable and they always produce nice results. Well, almost always, because I lied. Sometimes quad polygons can produce artifacts, and we can see that on this object. So we press ES key. If you look closely here, these 2 polygons, they look like triangles, but they actually are not. If you count the sides, for example, it's 1, 2, 3, 4. And if I enable my generator and just turn off, just click here somewhere to turn off this grid, and you will see artifacts also. Let me just increase the subdivision so you will see it more. You see here, that's a bulge. So how is that possible? We were under the impression that quads always produce nice and clean results. Yes, but the regular quads, non-degenerated quads. So let me just turn off hypernerves. And we will see here this polygon is an example of degenerated quad. Why? Although it technically is a four-sided polygon, when you're modeling, don't ever let two sides to be the same. Okay, those two edges that are consecutive should not share the same line, the same plane. Okay, so if you just move this point down, you will see it now is a quad polygon. So bear that in mind. Okay, those are the most simplest explanations I could think of. And never create such problems in your geometry. If there is an edge and you want something to terminate the surface, never use such complex objects. Always use a straight line between edges. Okay, this was just an example. Okay. Let me now press H key and I will frame all objects and simply let's delete all this. I can do that by Shift key or simply by left mouse drag and selecting all. Okay, hit delete. So we were talking about these little dots here. Well, this means like this object is currently hidden. So let me just click on this red dot again and the object will go in its default state. This gray means default state, and default state is basically the on. If I click once more, that would mean force the visibility of the subject to be always on, regardless of the setting of its parent and whatever you say. Okay, this is hidden. Okay, let's go to default state. So if I select this polygon and it's a nice and clean quad, let me just turn that grid off. It's kind of in the way. So the best bet would be to build your models exclusively from these nice and neat polygons. Well, since that is almost completely impossible, the things you don't want to do is to create something, let's say, like this. This is wrong because there is no edge here explaining the end of this geometry. Although it can work sometimes, although it can be fine, this is the generated polygon. There is not a flat surface between those edges. Okay, let me undo that. Also, you shouldn't do this. Although it technically is a four-sided polygon, there will be problems here. Okay, undo that. So always try your best to keep all these polygons, all these quads planar. And planar means, well, simply that surface between all these edges lies on the same plane. That's also almost impossible, but just try to keep those standards. Just try to keep them as planar as they can. Okay? I have another example, and that's topology example. So let me delete this polygon, okay, and I will unhide this topology example. So now if I press, for example, the S key, our cube, or not cube, basically half sphere would be visible. Well, you see, I created this object from a half sphere and I deleted these faces. And once when you delete faces, those vertices will stay. Okay, so if you want to clean all the vertices that are not connected to some geometry, then go to functions and optimize. And it will optimize rather or polygons or unused points or points. In this case, these are unused points since there is no geometry between them, and this is a tolerance value. What that basically means, if there are vertices, these points that are below or exactly this value, if you hit OK, they will be welded together. Okay, so okay, and it's always good practice to clean everything up after you model. Let's say this is a part of your model. Let me just deselect all. Especially if this would be a part of, let's say, organic model that you are doing, this would be considered as a really good example of nice and clean topology. So you probably heard about topology. What topology exactly is? Well, topology is a quality of the modeled surface. Topology is a consistency of the surface. Topology is a flow of these edges. So, not to get really too technical here, let me just explain what are the basic rules for clean and nice topology. Okay? One of the most basic rules is that the polygon sizes on your surface are somewhere in the same size. Okay, so they are, let's say, not exactly the same, but they follow some general size. Okay, so you can pretty much compare them. So there is no face that is double the size of any other face that would be considered a good topology. Okay, and the next and the most important thing about topology is this flow of edges. So if you have this nice and clean 90-degree cross sections of edges and there are no abrupt changes of that direction of those edges in your model, that would be considered good topology. Also, if your model is built exclusively from these nice, almost planar polygons, those quad polygons, that would be considered a really good topology. So for example, you don't have to exactly know what makes good topology. You will know when you see it. When you look at this, it looks nice and neat and clean. And if your models look nice and neat and clean, they're probably the best bet is that you have a really good topology. Okay? I know that probably most of you are eager to start modeling, but really try to understand that put under your skin. This must become your second nature to understand these basic rules if you want to model properly. I know it's kind of boring, but I really don't know how to emphasize this much more. It's almost crucial to your modeling skills. Okay? So in the next video I will talk about solving problems while you are modeling, because many people model and they hit a wall and they don't know how to do specific things while they are modeling. For example, you would be surprised how many people that are considered to be even experienced modelers don't even know how to create a simple hole. Okay? And then when you don't know the techniques, the modeling becomes a frustration. That is exactly what we are trying to avoid. Okay? So our next lesson will be about creating various geometry and solving problems while you model, and lots of little tips and tricks that I have for you. Okay, so see you in the next lesson.